second, that may not be accurate, unless you're counting me as first. North. That's very weird. The level must be frickin' rotated. Okay, that makes sense. I'm glad you and your dad like to talk. Will the compiler have different language translations for the error messages? Probably eventually. Right now, we're just working on the language, though. Would you handle it differently than you do for game localization? Probably not. I think we would treat it the same. I think we would treat it the same. Yeah, I mean, the thing about translating something like The Witness is it's large text with relatively esoteric ideas, whereas error messages are maybe not that bad. Although, if the people involved don't understand the technical topic, you could get bad translations for sure. Does it make sense to translate error messages? Why do you think everybody should have to know English in order to be able to program? That doesn't make sense to me. I mean, knowing some keywords and stuff is one thing because you just memorize them and it's fine. But like knowing what an error message means, if you get an error message and you have no idea what it means, that's really bad. That's very different from having to remember that the word if does a certain thing. That said, I have the advantage of English being my native language, so I just never really have that problem. Okay, so I think the deal here is that this transaction is going to pick up this stone, despite the fact that I'm pushing it. Okay, so we need to... Wait, did I already get... Okay, I skipped over the important part. Dang it. Okay. That's a linear interpolation. That's a... Why are so many linear interpolations? Oh, because these are... These are frickin' waves. Dang it, dude. Okay, wait, but there's no support move. Okay, there is a conflict. So this isn't gonna... Why does it think this is a player movement conflict? Hold on. So we have a lily. And this should be a rock, right? Or a guy. It's a guy. Okay, that makes sense. And this will say... Yeah, that was fine. Okay, so next conflict is the guy again. Oh, wait. It's the rock with the lily, which also is not going to be a conflict. And we didn't resolve. Okay. Wait, what? That wasn't supposed to work. That level was supposed to fail. I was... Like that. See that? See how terrible that is? That's what was supposed to happen. We have a very precarious time. How do I get my... Oh, geez. There we go. That's what I was looking for. Why are these rocks still falling? Okay, let's debug that. Let's debug that. They're falling indefinitely. And we never noticed. Okay. They are falling in place. They are falling at speed 0. Whoops. I just skipped over. Hold on. It's not supported. It really should be. Wait, what? Oh, these are... Wait, what? Okay, so it's not the rocks that you see on the screen that are being weird. It's rocks that are off the map. When things go off the map, they get crazy. Num out of bounds skips 1. So he like stops being supported. He like stops skipping as soon as he hits the edge of the map. So out of bounds skips doesn't even do anything. Like, I'm not even sure why this is even here, honestly. Let's just get rid of this. This is like really old. I don't know why that was there. I mean, I maybe had a reason once upon a time, long ago. Was it hard to marry Visuals Debugger? No. I wouldn't ever marry Visuals Debugger. You thought I destroyed objects. Well, you know, in a game like this, we go through many phases of what happens. Okay, so that rock is now getting destroyed. So before, they were not getting destroyed. So now, if I do this... Whoops, we don't... Yeah. Okay, we at least don't have these zombie things happening. So now you'll see what happens. See where the guy is standing? If you watch after he gets there, then Like here, see what happens here? He's trying to walk onto that lily and push the stone, and it doesn't work for some reason. And I thought that reason was that the lily then moves. Like this happened when I tried rejiggering the way time steps go in the simulate function so that I could take bigger time steps. And there's one piece of code where if I let it happen in one place, then this works fine. And if I let it happen in another place, then this breaks. And I'm not sure what to do about it. I might just make like a transaction log. The problem is, like all this, if I print all this information to a log, we could see what the difference is. And I suspect I know what it is, but let's see if my suspicion is true. So my suspicion is, here's my suspicion. So I'm going to pause right here. I'm going to break in push pushes, which is where I broke before anyone showed up on the stream. I'm going to break here. This transaction appears to complete. All right. What I want to know is, do we move the lilies during the same frame? So if I put a breakpoint here, does this happen first? Or do we finish? Let me see. Okay. So I want to know, do we hit that lily breakpoint or do we hit this breakpoint? And my guess is that we hit the lily breakpoint. Let's see. Yes. Okay. So the lily move and the other dude are happening during the same sim step. And my guess is that they are happening in the opposite order of each other. I'll show you guys what it looks like the other way. Where's my push pushes? All right. So this should continue on and fail then. Actually, no, it didn't. Okay, this is weird where if I pause the game, sometimes it doesn't frickin' fail, which also makes me really nervous. Like, I think it might have something to do with animation state. Like somebody checks animation state for gameplay purposes that they shouldn't, right? So like, if I just pause here, we're doing the same thing over and over. But if I just pause here for a while, then it works. So we're like, okay, I can't even really debug it the way that I'm debugging it because even pausing there messes things up. But that's great. Okay, so maybe I just implement this transaction log. And we do it this way, right? We save that out to a buffer, right? And then we do it again, and we just frickin' pause in the middle, right? We pause right here for a couple seconds, and then we go. And then that somehow changes it. Diff the logs, exactly. Now, there is a complicating factor, which is that I just added this pause before the stream. And so it might not be pausing everything that it needs to pause. But that's also a clue, because the pause isn't the only thing that'll break this, right? Like it's broken. So I'll show you guys. So what we used to do is we used to simulate a bunch of small time steps. And, you know, part of what we've been seeing, we would call this with many small time steps, right? And then part of what we've been seeing is that many tests are slow sometimes. So I wanted to cut this down a little bit. I wanted to cut down just the amount of CPU we chew, right? So we call this simulate less now. Or actually, no, we still call this the same amount, but it has way less stuff in it. It still has a substantial amount of stuff, but most of the stuff I moved into this simulate cosmetic only things, which is supposed to be stuff that has no gameplay effect, right? It's just updating variables that you render or whatever, right? Or particle systems or whatever. Now, this no check-in simulate per step here is code where if I see it's the same code as here, if I toggle this, if I comment this out and then uncomment this, then that same level plays back correctly, right? And so the thing is, all this does is update what animation is playing on the guy, which in principle should not affect gameplay decisions, but clearly is in some way. Okay, since implementing transaction log is going to take a minute, let me just show you. So we're going to do this, right? And, whoops. So we're just playing it back, no pause, and whoosh, it works fine. Okay, so if I play it again, or, you know, if I swap this, then it'll fail. And, you know, the timing of when we do this in principle should not matter. So somebody is being bad. See that? Boom. Okay. Somebody's being bad. So we have to figure out what. So we are going to diff the transaction logs. And I mean, the question is, okay, we should diff when transactions are closed. I mean, there's all sorts of extra stuff that we could do, but okay, first let's just even put the command in. How about that? Let's just start. Control L is like load game right now. Let's not do that. No, let's not make it a toggle. Do we have something for just L? That's error prone. If people hit L and it starts spamming them. Let's just say Control L and Alt L. Maybe Shift L. Okay. Okay, I'm going to do that. I'm going to do that. And then okay. I'm getting hungry, everybody. Gonna have some snacks. Where should I put this? Screw it. Okay, so when we close a transaction, we want to print the same information. So where do we print that? What string can we search for that tells me where I put this? It's just transactions. Quote, transactions, debug draw. Okay. Okay. I'm going to make a function here that says we're going to say header and moves are get transaction strings from it. All right. And then this is header. And this is, whoops, this is for moves it. Okay, so used for debugging to the screen and to the log. Okay, this returns a title, which is a string, and moves, which is an array of string, right? All right, so moves is title. I keep typing tile. Title is a string. Moves is a thing of string. Moves.allocator is temp. Okay. Oh, whoops. We copied some color stuff. Except, hold on. This is weird because I'm calling this title, but then this is the title of the transaction, so I don't know, man. Okay. 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 Return title moves. All right. So let's make sure that still works. Semicolon. That looks fine. What did I mess up? Oh, if I, duh. Okay. Whoops. That should be something where we have a better error message. Undeclared identifier manager. Okay. It's not working. Oh, because we didn't frickin' add any of these strings. So first of all, title is this. Like, if you want to succeed in the game industry, blah, blah, blah. Blah, blah, blah. Blah, 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 blah. Don't succeed in the game industry. It's not that good of a move, honestly. Okay, so we factored that out. All right, which means that we can do it elsewhere. So we can say when we close a transaction, we're going to say if do transaction log you know what? That's a function that maybe should be if developer. Okay. Title and moves is get the transaction strings for, is it called T? It is called T. For T, the transaction. And then log print transaction log. Okay, let's try this out. We're just going to let it spam to standard out right now. Actually, yeah, okay. Let's try it. So we're going to run it. What did I say? Control T to start the transaction? No. Oh, Control L. Right. I don't have a way to turn off testing of a single level. I made one for turning off testing of the whole game. Okay. Control L didn't work. Why not? Oh, because I didn't put, I bet I forgot to tag my thing as a command. Yep. Most common mistake, bro. See, know what your problem is before anything, and then you don't have to waste time debugging. Okay, there we go. Transaction log started. Great. Now I'm going to run the test. The problem is there's going to be like animation messages and crap in the middle of the transaction log, but we'll deal with it somehow. Okay, Alt-T. No, Alt-L. I keep wanting to do T. Okay, so we have all this stuff now. Oh, actually, it's pretty clean. There's a little bit. There's a particle shader in the middle of there. But we could even use that for entertainment value. Okay, so we're going to go into the log. Whoops, logs. No, it's here. Come on! Emacs, let me type. Jesus. I can't. At least I know now that I have it in a... this editor is from like 1906. All right, so let's just put this in. I'm just going to make a log here. Okay. It's like a timed thing happens and it puts something down in your notification window and then it never switches back to what you're typing. It's like it doesn't care what you were typing. You don't need to see what you were typing. Why would you need to see what you're typing? What matters is what Emacs wants to tell you. And it can't possibly just pop a notification like that up in the window in the corner because there's no such thing as graphics. You can't do like what we do in this game when we just say like transaction log started or whatever because there's no such thing as graphics. It's Emacs. Okay. We're saving this log. Now, we're going to go back to the game and do this. And now, okay, we're just going to test it once before we turn on the logging and make sure it actually goes correctly. And we'll see what's different. And what I suspect is that I need to log more information. All right? But we'll at least compare if the logs are like really... Like I suspect that we won't get the information we want yet. Because we want to know actually what's the frame number when transactions commit and in what order. And we didn't log that information yet. All right. So okay, so here, whoa. Okay, this is already going to be different because we have way more transactions, although I guess that's to be expected because different things happen after the midway point there. So let's do that. Whoops. Okay, so we're going to go here. And we're just scanning down the screen. Okay, well, we got this particle thing is different. So the times are different enough that bothers me. Because it's supposed to be a timed test. And we're already not reproducing the timing correctly. I actually should go into the level. So the guy who gets stuck is this guy. And yeah, so the x-axis, he's trying to go along minus x when he's getting stuck. The red arrow is x-axis. So 14,212. And then 14,206 is her. She's pushing stuff around. So we're getting the same moves, but like it's already more different than it should be. And I kind of think I know why that is. We're not really precise enough about something. See how like the amount of error is sort of creeping upward? Like, well, no, that's pretty high. Oh, you know, when we issue, I'm not sure. I need to think about this. So you'll notice the very first time, the first one, it's right on. Let's just look for this, okay? Second one, right on. Third one, not right on. Pretty far off. Actually, wait, the second one is off. So like already we have a problem. Like move number 2, guy move number 2 is already wrong. Now, let's step back a second and talk about what we're doing, right? So on one level, and this is very important, all right? This is a serious, oh, hey, welcome Raiders. This is an actual serious how to succeed in the game industry, all right? Because what we're doing right now is something a lot of people don't do, especially if they make games made in Unity, all right? And this actually has nothing to do with whether it's your own engine or anything. It's with how sloppy are you, right? Okay, so this started with, oh, there's a bug in the game where if we move some code around, we get different results than we expected, right? It broke a small number of tests. It broke, you know how we run the Benny test through the whole game? There's like 500 levels, like 5 extra levels failed when I moved that code. First of all, it was when I moved like 300 lines of code, right? Now, when I saw that those were different, I could have just shrugged. If I was a sloppy developer, I could have just shrugged and said, oh, well, I guess I changed the timings a little bit. Let's just re-record those 5 levels and move on. That would have taken the least amount of time. It's what most people would have done, all right? But then I said, no, let me binary search this 300 lines of code to figure out which bits of code actually caused the problem, right? And so that little loop that I showed you here, this loop was actually part of this whole loop. And this actually, like at first it was all this code in this whole function, right? So first I moved half of it back, or first I made this function that still happens per substep, right? And I moved it all back there and verified that that fixes the fails for one of the levels, this one that we saw that's consistently failing, right? And then I moved half of it over and it didn't fail. You know, you kind of do this binary search thing where it's like half, okay, still good. Let's pick half of the remaining half. Oh, that's still good. And then we got down to this whole giant loop, which also included this. And then I just looked through and said, most of this stuff does look legit cosmetic only, but oh, this part, animation could have something to do with something, right? So, then I isolated a much smaller repro case, right? I got this thing. Like, okay, if I toggle this back and forth, that breaks it. Now again, you could say, oh, well, mystery solved. Something in animation changes the timing somehow. I'm not going to deal with it. Just re-record the tests and move on. But no, right? Because like, I don't know what the problem is. And here's the thing. It's quite possible that this problem produces inconsistent results in gameplay, right? That maybe they're very rare. Maybe they only happen. So here, you know, I said 5 levels fail out of 500, right? So maybe it only happens 1% of the time when you're going really fast on timed levels, right? But we don't want that. We want our game to work 100% of the time, not 99% of the time. And so that's why you dig into this kind of a thing, right? So I want to know, why exactly is this not working? And I suspect there are going to be like several problems, right? So here's the thing is, then we added this transaction log, which is maybe something that you should have anyway. But then now that we have this, and we see that these times are different between these two logs, this is maybe a more fundamental problem. Like our playback is not reproducing, right? Which is on one level not that much of a surprise because we changed the code that runs in response to the playback. So you might just again shrug and go, well, of course we changed the code. It doesn't play back the same, blah, 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 right? But like, if you're that kind of made in Unity developer, then when you go modify your gameplay code later after you ship, you're maybe not going to be able to repro things the same. Like maybe the game won't behave the same. Maybe people's save games won't load. You have no idea, right? Maybe they'll undo halfway into their undo and it breaks. Like at some point, you have to know that your code works in a certain way, all right? And so in principle, we should be able to play this back and get exactly the same problem. Now, here's where it gets more fuzzy, right? This may not be exactly the cause of that fail. It probably is, but there might be multiple causes. So in investigating that failure, we might have turned up a problem that doesn't actually have anything to do with that code. Like, maybe if I change some other code that seems incidental, we would also get a discrepancy here, right? So we're on to a more fundamental issue. We're going to debug this. And it's just about insisting that your code really actually works rather than appearing to work, right? When you're a less experienced programmer and like making games is hard, there's this strong urge once something appears to work to say like, okay, great, move on. It works. Because it was hard to get there, right? But if it doesn't really work, you're just shooting yourself in the foot, right? You need it to really work. Computers are supposed to be able to operate deterministically and to function correctly, right? And the difference between understanding that and acting that way and feeling like that is a different universe than you live in, that's a huge difference. And some programmers never cross that gap, okay? Especially today. And it's very important to get there if you want to do high quality programming, right? Does that make sense? Do people get what I'm saying? What do I mean by transaction in the phrase transaction log? There is a 5-hour video on YouTube that explains all this. Let me link it for you while we wait for other questions. It's a discussion I did with Sean, and we explain how it works. Wait, somebody else, why is someone's unofficial stream have an upload of this? And why do I find that in a search before my own? Was that really 5 months ago? My God. My God, people. Couldn't have been 5 months ago. No, that must be a different video. Wait, what? What did I even find? I mean, I know you guys can't see this, but... So the thing I did with Sean is like... Okay, that must have been me working on it. All right, anyway. Here's the link to the discussion with me and Sean. And it's not really 5 hours because a lot of that is discussion at the end. So, you know. And probably if you watch the first 20 minutes where we do the most structured presentation of the idea, you'll like get it. And then you'll know if you want to watch more or not. It doesn't have to be 5 hours. Only for people who are super into it. Would it make sense to use a transaction system in a game with a continuous logical world? I would need more information about the game. Is it ever acceptable to just shrug and not fix an issue? Well, I have certainly done that and then regretted it later. So original Braid, when it shipped on the Xbox 360, had a problem very much like this, actually. All right. It had a problem where when you're doing the parallel universe stuff, where you do stuff and then rewind and then a shadow of you goes and does the stuff, that did not reproduce 100% of the time. It just mostly did. And the problem is I was just tired and couldn't program anymore. Like I was psychologically beat down, so I didn't fix it. Even though, honestly, I probably could have fixed it in a day, and some people hit that bug, right? Now, fortunately, it doesn't kill your game. It just like you do it over again, but it's not good. And, you know, we fixed it later on for the PC release. Now, fortunately, I had had enough of the correct attitude prior to that in development to get everything else working. Like the whole rewind system and all that had to be exact in order for the game to work. But that one part, that input replay system, was a little bit different than the rest. It was like a different subsystem and it had a bug, and I don't even remember what the bug was. But it wasn't this egregious, I don't think. But honestly, I never got to the point of just doing what we have here, of like logging the things. If I had done that, maybe I could have debugged it. Is diffing logs a common good debugging tool? I mean, it works very well for a certain class of problem. Definitely you don't want to like step through a debugger and try to write down a bunch of information for a case like this, right? So what you can see here is that because these timestamps are like different, it only happens to play back. It doesn't play back because it's exactly playing back. It's just like kind of largely playing back. All right. Now it's very weird because timed tests are supposed to at least give the input at exactly the same time. So what it may be is that the input gets buffered longer in one versus the other. Like maybe the controller is not exactly right, so that, you know, the one on the right takes longer to complete. Like, you know, remember when I said, oh, it's animation code for the guy that should be cosmetic only, but oh no, guys. Okay, I just realized one way in which the animation code is not cosmetic only. And that is that when you, like in the animation system, some of the animation states have parameters that control acceleration and deceleration of a character. Okay. Actually, this quite possibly explains why we don't play back, but it's a testable hypothesis, and I'll tell you what the test is. Um, so when you switch between animation states and all that stuff, you change the acceleration properties of the guy, and those acceleration properties will determine how long it takes to go from one square to another, right? Now, the transaction system is probably mostly robust to those changes because we don't actually care after you register the transaction where you are visually. But when we're going to register the transaction, right? When we're going to do these, and in fact, we can add more information here. I think this issue is commit time. We should be more clear about that. What was I saying? So it doesn't really matter if you change it after the transaction is closed, so to speak. But when we're going to close it, we estimate how long it's going to take if it's a controller proc based on what those animation parameters are. And so if we update the animation parameters differently, then we will change how long it estimates the transaction should take, which then will change when that transaction commits, because we say that the commit time is about 50% of the way, or actually it's not 50%, it's when the guy physically crosses the line between squares. So let's both log what we think the duration of a move is, and we already have actually an animation log. So we could turn on both logs and just see if it's different between the runs. And let's check this as well. So, okay. So when we say issue at, let's just say commit at, because we want to have consistent terminology. Issue maybe feels like close, I don't know. Okay, so that's when we commit, and we're going to say duration whatever. Right? Do we have a duration on the transaction? Yes. Whoops. And do we set that? Yeah. Okay. So we're going to print the duration of the transaction. And my guess is that that will change for the second move because we'll be in a different animation state. And then that's fine. And so then we'll further test my hypothesis in the following way. If that holds, we can look at this code, right? This code basically calls update animation with a given speed, right? Update animation does two things. There's a part that's just cosmetic, which is this animation player rendering skinning stuff. But this part, which I'd assumed was cosmetic before thinking about it, this animation graph update is the thing that changes gameplay relevant state. So My bet is that assuming that what I believe is true holds to be true, that then if I factor this loop so that just this part happens here and all the rest of this happens here, it'll still work. And then I can switch this very tiny bit of code back and forth between the two and create the bug or not create the bug. And that will be very strong verification that my story about the problem is the actual problem. Do you get what I'm saying? Why does the linear interp at the bottom appear to be out of order? At the bottom. I don't even know. 4.44 to 4.32. At the bottom of what? 4.44, 4.3. Yeah. So, okay. Basically, I see what you're saying. So this commit time for this transaction is earlier than this one. That's legal. That is legal. What happened was we determined that these transactions do not affect each other, which you can see obviously. Like this one affects these two squares. This one affects these two squares. Those coordinates do not intersect. So this is a lily move. Or no, this is a skipping stone. Sorry. This is a skipping stone. It's just moving while a guy is walking around. They don't affect each other, so this one is allowed to commit earlier than this one. That's fine. Even though it happens later, that's all fine. That's why, like, handling stuff like that, like letting that happen is part of like why we had to implement a buff system in the first place, and you can watch that YouTube video to make sense. Okay. So, what did we say? We're going to log this new information. And I suspect the duration is going to change. Okay, so we left the code. This is broken mode. So this is going to be log B if we're leaving our naming conventions the same. And we're going to turn on. Should I turn on the animation graph also? Let's do it without the animation graph. Just to get a clean picture again, right? So, wait. Oh no, this is non-broken mode. Right? Yes, this is non-broken mode, sorry. When we switch it to there and we have nothing here, that's broken mode. So let's go to the log, visit it. We'll get all this stuff. I don't know why I made that log B, but whatever. Okay, that's log B. And then broken mode, yeah, broken mode is going to be this one. Okay. It's easy to get confused about which is which. Broken mode. And you see how important iteration speed is, by the way? The fact that it doesn't take long to compile, the fact that the game doesn't take that long to start up. It takes longer than I would like. It takes a few seconds, but not that long. Like I can just crank through these things. Whereas sometimes people work on games where it takes 15, 20, sometimes 45 minutes to do what I just did in 5 seconds. And that is brutal, dude. It really affects your ability to solve problems. It's basically why you stopped using UE4. Yeah, Unreal Engine is brutal when it comes to iteration time. Absolutely brutal. Okay. So we're going to visit this again. Transaction log started and fail, and that's log A. Yeah, log A was the fail last time. It's the fail this time. All right. So same duration. Oh, it's the same duration. So my thesis about the cause of this was a little bit wrong. Now we do have a difference in duration, okay? So this actually makes sense if the animation is different, right? We have a different duration. I kind of understand that, although not, honestly not totally, because this might be a thing where we send an animation, where we need to send an animation message first and we send it later. That could affect things. Oh my God, guys. I just realized there is a fundamental logical problem that we have to deal with, which we'll talk about later. Wow. Anyway, so we might actually, for controller procs, actually not want to care about acceleration for certain reasons. Okay, I'll tell you what the reason is now, since we're on the topic. I just told you about how we play animations on the guy. That switches you around in this animation state machine. Where you are in the animation state machine controls how much you accelerate and all that stuff. All right? The problem is you don't want to play the animations or switch the animation states until you know that the transaction is not conflicting with anyone. All right? And part of that is knowing when it's going to commit, because we use that commit time in order to compare with other transactions and stuff, all right? And the commit time is based on the player acceleration. So when we estimate what your acceleration is from one square to the other, that's like when you're in the wrong animation state. It's before you push or whatever. So we actually don't want to really do that. And the problem is if we change that, that might break a lot of time tests. So we want to make sure everything's fixed before we do that. So fortunately, it doesn't really matter that much when we commit. So I'm thinking that we maybe just pick, we don't do our acceleration-based thing where we, like right now, to see what the commit time should be, we simulate your guy's acceleration as he crosses from square to square, but with the wrong parameters. And so it's probably better to just make it be a fixed time. Now, fortunately, because our system doesn't exactly care when that commit time is physically, because we just play the visuals separately, right? We can make that change and it won't affect the playability of the game in any major way, I don't think. Although, you know, to be honest, the difference between 0.3 and 0.4 is a lot. I mean, that's between 0.15 and 0.2 if you're talking about approximately half of it. Or, I mean, you can see the difference in commit times. It's 0.08 seconds. It's 80 milliseconds difference, which ain't nothing, but it's probably not enough to cause a problem. If you modify a line of code, you should compile a line of code. False. That is false. If your line of code is a data structure, good luck, bro. Secondly, you'll notice that all these systems that work super hard on incremental compilation, A, don't seem to compile that fast incrementally, and B, have all kinds of bugs related to incremental compilation and just failure modes and problems. You don't want that. Like, computers are so fast that for any reasonable size of program, you should just be able to full compile it. The fact that we can't do that today is embarrassing for everybody. That's what I have to say about that. Can you split code into DLLs and load during runtime? Sure, you could. Well, you obviously can't compile pure state, but you can compile behavior, sort of. I mean, even if you're just talking about compiling code, if you're in a relatively high-level language, a one-line change can change a lot of code. Like, hey, I changed the return type of my function that a lot of people use. Have fun with that. Okay, before I move on, so I was going to say, so all that stuff that I said about the animation being wrong is a problem, and it's causing a problem here in transaction 8, all right? But we have a problem before transaction 8. Transaction 5, which has the same duration and commit time of prior in both moves, commits at a different time, even though it's the same duration. So that must mean that the start time of this transaction is different. And so we have to debug that. So we already have 2 problems in the first 3 transactions. 2 different problems in the first 3 transactions. So that animation problem that I mentioned, we're not going to debug yet because we have another problem which is probably just related to timed playback not really doing the right thing. You're saying it doesn't make sense. It should go to some intermediate compiled state, and that intermediate state should then be compiled in whole. Why? Like, it should compile to something that is really cheap to compile in bulk. Do you know what's really cheap to compile in bulk? Your entire program. If the compiler is programmed by someone who's not a jackass, and if you're not trying to optimize everything. I mean, jackass is too strong a word because the problem is it's not people's fault that they all make slow code, because we have an entire profession that is based on superstition, and very few people are outside the superstition. And so kind of when you're caught up in that and you're just trying to do your best and you're trying to listen to everyone else's best practices and they all seem to make sense when they say it, you don't realize that it's all superstition and obviously false, because everybody spends all this time saying what you should believe, right? Compiling Chrome will take a lot of time no matter what. Why? I mean, it'll take more time than compiling less code, sure. But like, why does it take as long as it does? And then also, why is it so much code, right? Why is Chrome not 10% of the code that it actually is, right? Well, institutional bloat is sort of the answer to that. But then why does it take as long as it does to compile? Because the compiler's slow. That's really the answer. Wouldn't you rather compile 2 million lines of code per second instead of 1 million? Sure, but so Like how much you have to ask, how much complexity do I add to the system? And how much opportunity am I trading away in order to add all this complication of incremental builds, right? You have to ask yourself that. But all the dependencies also matter. That is true. I am also a firm believer that you should minimize your dependencies. I am also a firm believer that it helps to debug if your brain has neurons in it. So I'm going to have some neuro gum and thereby crank my neurons. No need to add complexity. You're not suggesting incremental builds. Then what are you suggesting? Because you're either compiling the whole program or you're diffing things in some way. Like, those are the two options. I mean, maybe not exactly diffing, but you have dependency analysis happening in some way, and then you're only recompiling part of the program. Each self-contained unit that is loosely coupled does not necessarily mean that the whole program needs to be recompiled. But you need to figure out what does need to be recompiled, okay? If I change printf to add an argument to the function, or let's just say changing the return type. Let's say I change the return type from a 32-bit integer to a 64-bit integer. Who do I have to recompile? Everybody who calls it. Who calls it? People in a lot of different other units. All right? Which means you not only have to track all that data of who uses who for everything in the whole program, you have to save it to disk, which ain't fast. And then you have to load it all from disk and then scan it to see who you need to recompile based on what's happening, which ain't fast. I mean, it's not necessarily the absolutely slowest thing in the world. You could certainly do it much faster than Visual Studio does, for example, but it is non-trivial. And I know that because my entire compiler is a dependency management system anyway, and it's a nightmare sometimes, dude. It gets complicated. I've spent years figuring out how to make it less complicated. It is not trivial. Like, what if somebody changes a pound define in the preprocessor in C++? Not only do you have to save what all the things were, all the actual language semantic connections, you have to save every program that expanded any particular macro ever. And then when those change, you have to change the people who depended on them. Like, fires spread fast is the other thing. Consider what you're saying from a more obvious and simple perspective. No, dude, I have to implement these things. You're saying that I'm making the wrong decision about the way I do things. And I'm trying to explain to you, as somebody who has been working not only on compilers generally for my entire professional life in one way or another, usually as hobbies until 2014, but like on this specific compiler for almost 6 years. Like, I have some experience doing this, and I'm telling you, man, it's not as simple as you're claiming it is. It just isn't. There is no, and you're saying, look at it from a simpler perspective, and I'm saying it's not simple. It just isn't. You actually haven't said anything with regards to this compiler or my way of doing anything. Okay. Well, I did assume that that was what was going on because, you know, I don't see all the chat. And what happened was I scrolled back a little bit and I saw you guys talking about incremental compilation and saying that it should happen. And so I did presume that that was in response to the fact that we're doing full builds all the time. So I actually do not know what discussion led to that. Okay. Let's log a couple more things. So move transaction has it should have a close time, but it doesn't. Let's add that. Okay. So we're going to save that out. And that is probably the thing that's different. So what we're going to see is different close times. And then this is actually probably more information than we want on the screen. Whoops, I put this in the wrong place. If you want to succeed in the game industry, make your arguments arguments and not return values. Okay. You're questioning why certain things are done the way they are. That's what confuses me, because many programming languages do incremental compilation, like Visual Studio does for C++. It's done it for 20 years. So maybe that's also why I was confused. Like, I don't know if Clang does, but GCC does. Oh yeah, no. Visual Studio has done incremental compilation forever, and one reason why I don't like it is because it's buggy sometimes. And also it takes a lot longer than I think it should. Okay. So we're going to go if brief else, right? So just for the purposes of putting stuff on the screen, we're just going to leave it here. And this is going to be close at whatever duration, whatever. Okay, so our thesis is I do understand what you mean when you say that it doesn't make sense to do more than what is necessary in general. I mean, yes, okay. I mean, that's how you make things fast, right? Broadly speaking, is to not do more than is necessary. So I'm 100% with you on that. However, there is a trade-off. Okay. This is subtle, right? There is a trade-off always between complexity and other, let's just say other things, right? Like speed or features, well, or I don't know, like budget. I mean, anything, right? In general, if you're going to optimize things, so making your programming language compile incrementally is a relatively heroic optimization in that it's a huge amount of work, both initially to get it working and then in an ongoing way, because you have to maintain that, right? And so it is worth it if the benefit is large, right? You're paying a lot for it, but if the benefit is large, then it's worth paying that much. And that's a broad statement about optimizations generally, right? If a so-called quote unquote optimization gives you a very small benefit, but is very costly in terms of maintenance and correctness and all these things and understandability of the system to the user, then it's maybe not a good idea because, well, because you spent opportunity cost on that, right? For this large cost that you're spending doing this optimization, you could have spent that time and effort and money and energy doing something else that was more effective, right? Firstly. And then secondly, here's the bigger point. Your system as a whole will either get better or get worse over time. Think of the quality of software is so imagine, I don't know, I'm not sure what shape the graph is, but imagine there's some unstable equilibrium that's kind of hill-shaped, right? So it's a hill with a mild slope on both sides. In general, if you put a ball anywhere on this hill, it's going to roll down. It's almost impossible to balance on the point of the hill. Just like if you try to stand a pencil up, you almost can't stand a pencil on its point, right? That's very hard. Anyone who's used to thinking about like hill climbing and energy and stuff knows what I'm talking about. It's a very common concept. So in terms of complexity of your software, you're either on one side of this hill or the other. Either it's simple enough and clear enough and the people working on it understand it well enough and communicate well enough that you can make forward progress and make the software better and better over time, in which case you're going down the left side of the hill, right? Or maybe it's starting to get bad and you're sort of toward the top because people don't communicate that well. They don't understand it that well anymore. It's kind of complicated. Nobody really knows everything. Then maybe you're slowly rolling to the left or slowly rolling to the right, okay? But at some point, things are just kind of bad, and you're on the right side of that curve rolling broadly to the right, where right is not good in this case. Right is like upward on the graph of number of problems that you have, right? And so it's important to be on the correct side of that hill at all times. And the problem is that overall system complexity pushes you to the right on that graph. You want to stay on the left on that graph. And adding a very large, all-encompassing optimization like incremental compilation spends a lot of very valuable currency that pushes you to the right, which you may not be able to afford, all right? Do you guys get what I'm saying about this graph? Like a program, when it's small and simple, like it's easy to make progress at the beginning, right? because there's just not that much complexity. You're just cranking along. Your program doesn't do that much left yet. So you're like on the left. Your program is small. You're like way down this hill, right? But as your program gets bigger, you're kind of climbing up the hill until you reach some danger point where you don't really understand things anymore. And then you start to slide down the wrong side, okay? And so when you're very far on the left, you're able to make progress quickly. And when you're very far on the right, you can't make progress or you make negative progress. And so a big part of software system management is staying on the left side of that curve. It's a huge part of it. And that, for example, is why we, in this compiler, do not do incremental compilation. Also, I just don't think the benefit is that big if the rest of your compiler is good. So these are complicated issues, but that is my opinion about all of this. Okay, let's actually work on the game. Wow, it's 8 p.m., guys. What the hell happened today? I don't know where the day went. I spent 2 hours in line at a store. That was part of it. Because when you can't go into the store because of coronavirus, only 1 or 2 people in there at a time, takes a long time. Okay. So our thesis is that this is not right. And so the reason why that might not be right is because either the replay system is asking the transaction to play at the wrong time. It's either queuing the control at the wrong time, or the control is being pulled off the queue at the wrong time. I think it's queuing the control at the right time, but it's being pulled off at the wrong time. That is my belief, but we will see. We're going to log both of those things. In enact move, we're going to put all this in the transaction log, even though so when we say enact next buffered move, here we go. Okay. So we're just going to print the frickin' move real messy like. We're going to say if do transaction log print transaction log comma enacting move at time colon move. We're just going to spam the move in there. Time is manager.current. Is it? Hold on. What do we say? Yeah, manager.current time move. So that's going to be spammy, but there's going to be less of those than new transactions. Actually, no, you know what? Okay. Let's keep it short. Okay. So we're going to go move.move info move. No, it's not a move info. Move.action type. We're not going to print all the details. We don't need them all. And then ID string, what's it called? Yeah. id string move.id. Okay. So that's when we pull moves off. And then when we push moves on, that's going to be in tests. Buffer moves for current timed frame. Okay. Okay. All right, let's do it again. Okay, we should be in broken mode now, which is log A, right? So let's try that. We're gonna do this. Broken mode. It's reassuring that our adding of logging is not breaking stuff. Okay. Didn't really add that much text, actually. Whoops, we forgot a new line. Let's fix that. I've been meaning to maybe make our log function add new lines if they're not at the end. Let's do that. Let's fix this that way. Let's squash the problem. Oh no, it's not actually the new line missing. It's, well, it sort of is, but the print's failing. I guess we don't store IDs in the delta. Anyway, I messed up my buffering. Buffering move whatever. Oh. Wait, no. There's 3%. What? Oh no, we did just... Oh no, there's 4%. I'm a goofball. We're not going to fix the logging right now. You know what I am going to fix that's annoying me? This looks stupid on the screen. That period. Sometimes you have to fix the important things. Okay. In fact, let's just do this. Better. Okay. Okay. Wait, what? Oh, we made the same mistake. I should have fixed the logging. We're going to stay on target, though. An acting move. See, we had... I changed my mind in the middle, man. Yum, yum. We're going to have some pita chips. We need to debug this attempt to handle an ocean change as well. There's a number of problems that we need to debug, but this one is important. Okay. Looks better. Looks better. Let's do the other one. So we're going to go back here where we haven't been in a while. And we're going to toggle this. Going to rebuild. And we're going to go. Log go. Okay. See, we have long lines sometimes, which wraps, and that's a little bit annoying. Okay. So we're buffering the first move. All these numbers are the same for the first move. Okay. Buffering at the right time. And acting at the right time. Somehow the commit time is different though. This is interesting because I thought that the problem was going to be one of these numbers, but it wasn't. So whereas we have not solved the problem, we have learned what it isn't. And then the other very weird thing, we have a commit time here. The close time and the duration are exactly the same. So next I'm going to step into that function I told you about that estimates when you cross the line. And now my new idea is that either we are in a different animation state between these two, or for some reason we're in a different visual position, either of which will hose us probably. Maybe both of those are different. Wait, what? Oh. Okay. This, I believe, will give us something good. Whoops. Okay. Okay. So I believe it's the same up to here. Starting position is the same. Interesting. Ending position is not the same. Velocity is very much not the same. So it is not the starting position that is the problem. It is probably animation parameters. Because that is what would be changed by that code that we moved around. Even though it's not the right animation parameters, for reasons that I said before, it would change what state you're in, which would affect this. I'm tempted at this point. Let's just verify that that's the problem. Okay. And then once that's the problem, I'm going to nail it down. Okay, so here we go. So do guy controller. Get decel distance. So that's, oh. Well, test for deceleration, all these things. Now, I don't know how to print these without hella spamming. Wait, what is test for decel? Oh, this is like, oh my God, guys. This is so bad. We call this function 300 times. We should lift this out of the loop. Okay, so that's one thing. This also might do something different potentially at some point. Maybe. We'll see. Like if we did something incorrectly, you know, if we see another move buffered or not, we'll change what we do here. You know, actually, we don't have to lift this out because we're not going to run this function. We're not going to run this function at all because the whole point of this function is to simulate what we think is going to happen. And the thing is, we don't really know what's going to happen until we play the animation. So, like, we're literally just going to replace all this with a hard-coded number. That's all. The problem is this is going to be so spammy, dude. We're going to do it though. We're going to verify that what we think is happening, and it's going to be super spammy, and then we're going to delete some of this. So far, the log messages that we've been putting in are useful, broadly speaking, for future debugging. Because, you know, next time there's a transaction problem, just leave all that code there, turn it on, maybe it'll help you, right? What we're about to put in would make that impractical. So we're going to put no check-ins on it. We're going to say here, you're going to put no check-in there to be creative. See, this is all weird. Like, I don't want to put a print in here. We'll just, we're going to print before we call this each step. So that'll tell us something. Wait, this isn't even what, okay, we wanted here, actually, sorry. We wanted, like run speed, velocity. Okay, we want these 4 functions. Or values. Run speed, whatever, velocity. Actually, velocity is last. Because that's the thing, that's the output, sort of. And these are the inputs. Okay. Now, so that's do guy controller. And then this gets run 300 times. from here, so, oh, we forgot if do transaction log. So we're going to do that here too. And we're just going to say every single step. So if we return early from that function or something, we'll see the outer print and not the inner. If we go a different number of steps, we'll see a different number of things. Oh my God, this is going to be terrible. But sometimes you do what you do. Whoops, whoops. Hold on, hold on. I didn't turn on the log. Didn't turn on the log. Okay, bam. I think we left it on success. No, we left it on fail. Okay. At least I hope it's on fail. All right, bam. Okay. Look at all, oh, that's not as spammy as I thought, guys. No problem. Okay, we run it potentially 300 times with a fixed time step of 0.01. So you would only really run it 300 times if the move took 3 seconds, which moves in this game don't take 3 seconds. They tend to take like 0.2 seconds. So I still don't know why it's this few things. But whatever. Okay, we are going to go to log A, because that's our fail log, and we're going to do this. This is the new log. And then we're going to go to the other one. We're getting there. And you know, like, this will have taken us like an extra hour, hour and a half to dig into this, but the game will be much better for it in the long term. Whereas we could have just shrugged our shoulders and moved on and said made in Unity in the splash screen. But that is not what we do here. That is not what we do downtown. I hope I remembered to turn it on. Okay. Okay. So, everybody, this already looks kind of different. Wait, what? Oh, no, it doesn't. All right. So, let me just look down at step 10. Oh, wait, the whole first move is fine, right? Didn't we determine that? The whole first move was fine. So we have start at 10.0 for the second move, end at 10.45 something 0. Oh, that's the estimation for the first move. Good. Okay, all these numbers came out the same. So great. So there's not like, you know, there's a number of reasons why you might not run deterministically. One of them is like an uninitialized variable gets used and then all craziness happens, right? Someone's picking a non-deterministic random number that you didn't know about. Those don't appear to be happening in this code because we're getting the same result. Although there could be some code path with that, but I don't think so. Okay, so this is the next transaction, or that's closing transaction 2. All right. Oh, and these are actually running the guy. That's confusing. Okay. This is actually doing this, but graphically and with a bigger time step, which is, you know, because the 0.01 is like, It's just to have a consistent thinger. Okay. So down here, run speed 3.51, it's consistent. Stopping decel false, turning decel false. Velocity 6.09441 minus 1.75. So we're still the same. Down to there. Okay. Okay, we want to ignore the ones of these that don't say step whatever, right? So the ones that say step whatever, that's our estimation that we use to create the transaction. These are actually running around. I should have added a parameter to not draw them. Because remember, that function gets called both to estimate what happens and then to actually make it happen. Okay, so this delta, let's just look down here. Is this different already? Yes, this is already way different. Like the velocity here is super different in the y. Okay, where does it go wrong? 7244886175550. Okay. It's already different. Okay, I am super confused now. So it's different and not because of any of the variables that we are drawing, guys. That's bananas. I mean, it's not bananas. I just figured it would be one of these. These are the same. We have to keep looking. We must keep looking. Okay, let's this will all be solved if we just replace this with a constant. But we're not going to do that yet. We are not going to do that yet. Okay. It's in this file. Okay. We're going to call this with here and then okay, now we have to figure out some other things. So it's not the run speed. Oh, it could be speed scale. Where does that get used? It could be speed scale. We're going to delete these. We're going to comment this out so that we remember, because it could take several iterations of this. Okay, speed scale. We're going to leave velocity because what else do we do besides speed scale? Get decel distance. Oh, we changed stopping decel after we printed it out, so we have to do that again. All right. Let's put this down just down here. Stopping decel whatever. Decel whatever. dv dt par. What is get dv? Get dv dt uses Excel time. We don't know what Excel time is. All right. Okay. It'll be one of these, hopefully. Stopping decel, dv dt par.x, dv dt par.y, get accel time of guy. So many things to print. Okay. Isn't it fun? Isn't computers real fun? Oh, dvdt par is not a vector, bro. Bro, it's a parallel to it. Yeah, it's parallel in 2D, which means it's 1D. Bro. Okay. Okay. Really? I told you guys the Zambia story last year? I didn't realize I told you guys about the Zambia story. All right. So we're on succeed now, right? Which is log B. I could stop it already because we never need to look that far. Okay. There's log B. Okay. Lots of new information. And let's edit the code to do this. I almost should just put this in a runtime variable at this point. So we can just toggle it, just stay running and just toggle it. But we have to rebuild anyway for like at least the logging messages, so whatever. Okay. Okay, still failing the same way. Okay. Okay. So we're saying that it's somewhere here, enacting move delta for 0, 0 at 1.137571. Okay. Speed scale 2, stopping to sell false, use a DVD far. It's already different in step 1 because accel time is different. Accel time was one of the parameters in dvdt par. So this is our poison here. We have found the poison, and it's exactly what I said. When we look at get accel time, it's going to ask what animation state you're in, and we can print that. Okay, get accel time. Whoops, I'm in the wrong file. Get accel time does this. And see, if the state has an override, it returns that, otherwise whatever. So we're just going to say, hey, the guy's in a different animation state, which makes sense because we call the animation graph code differently. See, so we verified our hypothesis. I could have just assumed I was right. Let's go all the way to the end. I could have assumed I was right, but I wanted to make sure. Like I want to fix this. It's important. In part because of that story I told you about not fixing it in braid. I want to fix it this time. For that reason, I regret my shady past, right? My mistakes. You know when you say like, if only I could go back to high school and be cool this time? Well, it's like if only I could go back to that indie game I made and do it better this time. Okay, so really it's Excel time. And we're just going to put state. That's going to be state name and get Excel time guy. And state name. I think that. Hold on. Right. Yeah. We'll do this. This is the same. We'll say add. Yes, there's two things recursively called the animation state. Okay, don't at me. Don't at me. So this should say different animation state names. There's no name in what? Well. Oh, it's current node. Node is so we subscript something by that. M.nodes. What is M here? M is the graph. Where do we get that from? Is that on human animation state? No. Where's the graph? Where does it come from? It's probably on the entity. It's on the animation graph. And this is node.name. Boy. Boy, that was fun. Now watch it crash because I did it wrong. You were head of the computer lab. You don't want to go back to be more cool than that? Well, okay. If that worked for you. Okay. Okay, we know what we're going to see, but let's go see it. So, log started. So this is our fail, which is log A. Wait. Oh, yeah. Okay. See, so like this is one state, it's giving us one Excel time, it is another state, is another Excel time, which is fine as long as that matches the other thing, which it will not. Which it will not. Whoops. Okay, hold on. We've got B on the wrong side. Let's put A on the left, B on the right, and B is the succeed, A is the fail. Okay, so again, the first move is going to be fine. The next move, we say enacting this. There we go. We're in different animation states. The thesis that I told you guys like an hour ago about what the problem is the problem. And that is why we are not reproducibly running in these two different modes. So now we probably should fix this so that visuals are in sync. But before that, like I said, this estimation thing is dumb. It doesn't even work. So, okay, but this is what we did all this work to do, is figure out exactly. We started with a very mysterious problem, right? Like, oh, our game kind of mostly works, but it doesn't work if you get really picky about it. And again, most programmers' urge at that point is to say, oh, let's just not be picky about it. It pretty much works, right? We didn't do that. We dove in, we drilled into what's happening. I kept going and going until I see exactly the difference about why it doesn't run the same way in both modes. And now I am fixing that. Good luck doing that if you use Unity, by the way. Because what you'll end up with is like, there's some point deeper than which you can't go. I mean, maybe if you have a source license, you can go deeper. It'll just be too complicated to understand. All right. So we're going to delete this. We're going to delete this. We're going to delete this. Okay. We're going to delete this. So, well, this whole function, by the way, is going to go away. This function, we're going to delete. Okay, we're going to replace that with a hard-coded value. What is that value going to be? Well, what's our typical move duration? Well, sometimes it's about 0.1 seconds, right? Oh, wait, commit. Okay, hold on. This is about 0.2 seconds to go across. But that's when you're not already moving, so sometimes it's going to be less. I mean, let's see. This is a thing that we can tweak later, right? It's not that big of a deal. I just want to get a good initial guess. So that's 0.15 something, right? I want to make it like 0.17, 0.16. All right, so in all that variables, we're going to make a thing in gameplay settings called controller proc delta between physical moves 0.17. Let's call it DT. DT before physical move. And we're going to have to explain this. But before we explain it, we're going to make sure it is what we really want to do. Because you don't... Oh, wait. Did I say 0.16? Okay. So instead of calling this estimate tangler, right, we're going to say estimate is gameplay settings dot whatever, and we're going to say, check in explain. Okay. Great. Now this might not reproduce actually because we changed what happens and it's a time test. But it should do the same thing both times. Oh, you know what we should do? Let's log it again. We don't have all the logging information that we had before, but we do have all the transactions, right? So I didn't actually change anything. It should succeed again. We're going to log test. By the way, this is not a unit test, right? This is an integration test. This is the entire game running. You can't find this kind of bug with a unit test, right? Unit tests do not help you with this. This is a kind of bug that only emerges when the units are put together, right? Okay. So we're gonna put that in. It probably doesn't matter. I think it's going to succeed both times now, but we're going to put that in B because B was our succeed before. And then we're going to go to sim and we're going to toggle this back. Now this before was a fail and maybe it'll be a succeed now. Maybe it won't, which will be interesting. But I'm guessing 85% chance this succeeds. Maybe I'm overconfident there. Let's find out. It didn't succeed, bro. All right, well, I was overconfident, but not necessarily in that bad of a way because, sometimes there's more than one problem. All right, let's see. Or sometimes, sometimes there's more than one problem. All right, whoops. Okay, let's see where the difference is now. We've deleted most of our spam because a lot of that spam doesn't even happen now because we have a hard-coded estimate. Okay. Let's make sure we're looking at two different files here. Okay. I should clean up this 00 because that's just noise. Okay, so same. Wait, why am I on 17? That's not where we wanted to be. I was like same, and it's like, no, it's not. Your brain is freaking out if you think that's the same. Okay. Transaction 2, one move, 1.147435. Okay, this is the same. Same buffer time. Same enact time. Same commit time. Okay, we made it further through the log. We used to fail on transaction 5, right? We don't anymore. Okay. Well, and like I said before, that reason why we were failing, or we weren't failing in a hard way. We were failing in the sense that I was looking at the numbers and they were different and I was displeased by that. But the time when the actual problem happens in the level is much later. And that one, like I said at the beginning, could be due to a different reason. And I think what we're finding out is it was. I sort of suspect I know that reason too. I think it has to do with the order in which I don't know. Let me not speculate yet. I kind of think I know. Okay, wait. It's already different on transaction 8. Why is that? These have different close times. They have different duration. What? What? Why do they have different durations? Somebody else. Wait, what? The duration is being determined by something else. Here it was being determined by that acceleration. Here it's being determined by a different thing. It's 3-1 or 4-1. Oh, and you know what? Actually, it wasn't the duration that was different before. It was the commit time, which actually, okay. Actually, the next transaction doesn't start until the previous one runs out its duration. So the commit time being different was bad, but isn't causal of this being at a different time, which is why this one is still wrong. Okay, so our close time is different, which means that's a little weird. Okay, no, because our enact time is different simply because, well, the visuals are taking a different amount of time. That's, okay. For the same reason that estimate function took different amounts of time. Now the actual guy running around in the world takes different amounts of time because it calls that same code. And that is different in both these cases. But that's okay. That is predicted by moving that code back and forth because that little snippet of code is what changes the animation states. So my prediction is we can fix it by doing what I said like an hour ago and breaking that out into 2 pieces. The part that's cosmetic and the part that is not cosmetic. Now, well, let's do that. Let me clean this little sniglet up, and then we'll do that. Wow, I had a lot of caffeine today. I'm buzzing. I'm buzzing, people. Maybe I'm just high on life. All right. How's it going, everybody? How's it going? It's 6 a.m. Why are you watching this? I don't know. Are you mentally disturbed? What is your problem? Where do you live that it's 6 a.m.? Berlin? Because I think we're usually 8 from London. Sweden, okay. Okay. How's that coronavirus treating you guys these days? Probably better than the US. Shots fired? Not really, because, okay, so a lot of people criticize the Swedish approach. And on the one hand, it may be criticizable, but on the other hand, 100% of critiques that I saw of it were stupid. Like literally nobody on the internet was able to form a critique of the Swedish strategy that made any sense at all for even one sentence. So, yeah. I don't know. I figure it's not up to me to have an opinion about whether the Swedish approach is correct or not. That's up to the Swedish populace. but the critiques that I saw of it were terrible. Anyway, I'm pretty sure the USA has more cases per capita than Sweden by a lot. So anyone who criticizes Sweden should rely on criticizing the USA much heavier. Most Swedes find it terrible, yeah. Well, hopefully when they find it terrible, they're using at least reasonable arguments. Like the number one thing that I heard about it was they have way more cases per capita than neighboring countries. And it's like, yeah, but they're also further along in the pandemic in terms of, the number of people who have been infected and therefore theoretically are immune, right? And so if you're going to compare cases or fatalities or anything between the countries, you have to actually fast forward time on Denmark or whoever else you're comparing against and add hypothetical future infections and fatalities for that amount of time and then see how it looks, right? And nobody ever did that, which shows me that they're not thinking about it like at all, right? Now, after doing that, it may still turn out that you don't like the outcome on the Swedish side, right? But at least do that. At least have a brain. Isn't like most of the US resurging? Yep. The problem with this is that they say you do not become immune if you go through. No, that was a rumor that was going around, but as far as I understand, almost nobody believes that right now. Yeah, New Zealand is the ideal place to be right now, honestly. What does the complete mean in that conditional? It means that this is about an enum and you have to cover every case of the enum. Otherwise, it's an error, right? Because one common thing that you do is, say you program this one day, you program 27 things just like this in your program in different places, where you're supposed to do something for all these things. And then one day you go and add a new enum value and you forget to go do all of these, or maybe you don't know where they all are. And then bugs happen passively in your program, right? And so this is a way of preventing bugs from happening passively. You demand that this must cover all the enums or it's an error. And so then if you add a new enum, you get an error here, unless you handle it. Why assert? Because this value is really whatever the size was, right? When you declare an enum, you say how big it is, right? Is it 8 bits? Is it 32 bits? The actual value in that memory might not be one of the enum values, right? It might be 67,412 because you read it from somewhere bad. So the assert is to handle that. Yeah, it's basically two different things, right? The assert is to handle other kinds of runtime problems. And this is to handle the logical flaw of not handling all your cases. I kind of want to go to New Zealand. I might go hang out with my friend in Iceland. That would be fun. New Zealand has Gandalf. Well, Wait, OG Gandalf passed away and got replaced by Harry Potter Gandalf, right? Didn't that happen? Is Harry Potter Gandalf still alive? Or are they both gone now? I'm thinking of OG Dumbledore. Wait, what? Did I have it that backwards? I honestly don't care much about Harry Potter, so maybe that's the problem. Okay, so Harry Potter got the swap. Right, okay. All right, gotcha. Ian McKellen, who's still alive. That is good because Ian McKellen is a good actor. We need good actors to stay alive because holy cow, movies are bad, and anything that will help them be slightly better, like good actors, is good. All right. I don't know if he's retired at this point. I feel like I saw him in something not that long ago. Okay, so what was I even saying? I was saying that let's factor this into two things. We're actually going to leave something here. We're going to leave this here, update animation, but it's going to be a different ting-tangler. This is going to be update animation cosmetic. This is going to be update animation graph. All right. And this happens per sub step, just like before. This does not, because this shouldn't really matter. And now the problem is a lot of people call update animation, and this is going to be a pain in the ass. We may have to do it a different way than we're doing it. But anyway, okay. This is going to be update animation cosmetic. And we're going to have update animation graph. One of these may not need everything. Okay. So this is going to be here. And then let's just look here. Actually, we can just do this. Okay. Okay, see this is not cosmetic necessarily, because again, this can change our states. So this part, the skinning and all that is theoretically cosmetic. There still may be something there that makes it non-cosmetic, but we're going to do this here and this here. All right. We're just going to return there. We're going to do that. Then we do fidgeting. Okay, and then update animation cosmetic does this. Endgame was great. Well, that is just where you and I differ. If you mean Avengers Endgame, If you mean the end game of Lee Sedol versus AlphaGo, then maybe. Okay, so we're using animation speed. We're using DT. I don't think we're going to be using animation speed here. We are using DT. Okay. So, yeah. So we don't need this speed at all. Now the scary thing is, all right, so everything that calls update animation theoretically we have to do this for everybody who calls frickin' update animation. Wait, whoa. We were calling this twice. Oops. That made things go twice as fast, probably. Oops. Okay. This is an old thing that I did where it's like you could play an idle animation. You don't have to make a graph for this. You could just play an idle animation and then do a different. We might take it out. It might not be worth maintaining. Okay, so for monsters, we're going to do all this, I guess. So it's only for players that we factor out. And having all these loops is dumb. Eventually we're going to do this differently, but, you know, maybe it's not that dumb, but whatevs, man. Whatevs, man. Rocks don't even have animation graphs. Okay. So maybe I messed that up. But we'll see. Let's just do this first. Undeclared identifier update animation, right? Because I didn't do this. Okay. Before we run the test, let's theorize about what should happen based on the code. I mean, I think it should succeed, right? Because the animation graph is running per step, and the cosmetic is running only once for the entire frame, right? Should succeed. Yay! Did pushing rocks get worse? No, not really. Okay. That's just from the test. All right, this is great. It took us a while to get here, but here then, we want to update guide animation graphs per simulation step because this controls accel decel for the guy, which determines when transactions end and thus when chained or blocked transactions begin. Okay, we're doing that right there, baby. So now, here's the thing, guys. I changed the commit time to a constant. And I feel like that is likely to break some levels, so we have to Benny test. We have to do a full Benny test, see what the pain is, and then fix the pain. We must fix the pain. And then we have to comment why that variable is a constant instead of the approximation that we did. And then maybe that's a good night's work. Are they going to have to rename the Sega Master System? Okay. If we're going to do a full Benny test, we need to go fast, like Sonic. We need Sonic fast. Frame rate is still low sometimes, but we're getting there. We're getting there. We're making it faster. Whoa! Okay, that is now a broken test, for example. But it's not a surprise, honestly. See where our time, oh, stack trace disabled. Bro. So I would expect some percentage of time tests to be broken, and the longer they go, the more likely they are to be broken. Any questions about either what we specifically did, programming-wise, how the system works that we were working on, or how to program video games? You've been reading the book I recommended on geometric algebra. No, which book was it? The Lunesto book or a different one? Yeah, there isn't one there in the Insobot, so it must be the Lunesto one, maybe, or is it the game engine one that I don't remember what it is. Is the animation graph kind of like the skeleton? No, the animation graph is a state machine that controls what should happen. So it's things like I'm running, I'm turning right, I'm whatevering, right? And so each of those states might go to a different state depending on what's happening in the game. And then each of those states has things like, for example, what animation we play when we're in this state, but also things like how fast do we accelerate and, all that. Geometric algebra for computer graphics. Okay. I haven't actually read that one, but it seemed good. Wait, why did that? Some of these levels take a long time at the end and then say succeed. I kind of don't get it. All right. That was a fairly involved timed level, and that one succeeded. So I have hope. I have hope that most levels will succeed. What else is going on, people? Is there a way to turn off water simulation? Not currently. We certainly could do that if it's the main problem. I don't actually know if it's the main problem. I kind of feel like it isn't. But it might be. And it might help, honestly. And even if we don't turn it off, like just to exercise that, we could turn down the number of particles if it's the particles taking time, right? For animating joints, could one add noise to the joint transforms to make walk cycles less robotic? I would not do it with noise, honestly. The fad right now is deep learning, man, right? So I would have something like that generating variations. The thing is, like, noise by itself isn't going to look good. What looks good is when your guy responds to the environment, right? It's when his walk changes slightly because his foot's on a little bit of a hill. That's what makes things look really good. Like less robotic, like mocap I don't think usually looks robotic. So if you want less robotic, just mocap. But if you really want to take it to the next level, it needs to go. You also read Hypercomplex Numbers. It was great. You don't understand well how to rotate an object with quaternions. Yeah, I didn't really learn in that order, right? I learned quaternions first, like practically, like people saying, here's how you rotate stuff with quaternions. And then I read stuff like Hypercomplex Numbers to like get more into it. But it probably works in either order, honestly. So here's the thing to know about rotating things with quaternions in 3D space, all right? So because space is 3D, because our space is 3D, every rotation has a 1D eigenspace, right? If you remember what that means. I mean, unless it's the identity rotation, in which case there's 3D eigenspace. But like that 1D eigenspace, because the number of dimensions is odd, is the axis of rotation, right? Or not exactly that it's odd, but whatever. It's the axis of rotation, right? And so a quaternion, you can sort of refactor it or look at the math as just 3 of the components determine the axis, right? So if you have X, Y, Z, and W are your components of your quaternion, X, Y, and Z mostly determine the axis, right? And then, but it's times, the cosine of the angle or the sine of the angle, one of those, right? And then W is just the sine of the angle or the cosine. I think W is the cosine. Anyway, so that represents a rotation by a certain angle around a certain axis. And in order to understand why the math does that, like why does multiplying by a quaternion do that, you can actually look at what the multiplication does. So, some of these geometric algebra books, especially the ones I like, and also linear algebra done right, it talks about breaking things into parallel and orthogonal components, right? So if you have a rotation around some axis, then, some part, if you take the vector from, I don't know, the origin to your thing, imagine the axis goes through the origin for now, right? Just to keep it simple. So you've got an axis going through the origin, and then you've got a point over here, right? So this vector, part of it is parallel to the axis, part of it's orthogonal to the axis, right? The rotation does not change the part of the vector that's parallel to the axis. That stays the same, that's the definition of that being the eigenspace, right? Well, with eigenvalue 1, which it is if it's a rotation, okay? The part that's perpendicular or orthogonal then rotates around the axis by a certain amount, right? And so what you can do is you just do the multiplication and you see that that's the effect of the multiplication is to do that, right? If that makes sense. And you can do it, if you want to make it really easy for yourself, you can pick very simple, like, components, for example, like, okay, my axis is, the axis of rotation is the x-axis, right? So 2 coordinates are 0, so most of the terms drop out. And you can do that and just see why it's a rotation, if that makes sense. Are there good reasons to use quaternions other than that they interpolate nicely? Yes, you don't get into singularities with them. And it's a constant energy. So a quaternion, if you move a certain distance on the unit force sphere, that's an equal distance in rotation space always. I mean, I suppose you could pick a picky definition where it isn't, but like, so for Euler angles, depending on where you are in the Euler angle space, for example, changes in parameters of the same size can have very different amounts of like resulting spin on the object. Do the entities of your game have a single quaternion? Do you assume a default position and then implement rotation by the quaternion of your entity? Okay, so entities in general have a position, right? A 3D vector that's like, what's their position relative to the origin, right? They have a quaternion representing the rotation relative to the default world space frame of X, Y, and Z, right, pointing up. And then they have a scale factor, although we don't usually use that. A uniform scale factor. Well, actually, we have non-uniform scale in this game because we use that for inanimate objects. Why are there so many fireworks going off? People are bored and they're buying a lot of fireworks. I guess we're coming up on 4th of July, so it makes sense. Anyway, you could ignore the scale, right? Scale doesn't really matter. And in fact, a quaternion that's not unit length will scale your object as well. So you could, if you wanted to, put scale in the quaternion, although like if you want to animate scale, you probably want it separate. But yeah, so we tend to have a 3D vector for position and a quaternion for rotation. Something did get a lot slower for the Benny tests. It might be particle sim because I did raise the number of particles, or I at least changed it. It's probably smaller on some levels. We'll see. After we fix this, we'll try to determine what that problem is. Okay. What's going on, people? Is there a particular reason the game doesn't run headless when doing the Benny tests? Yes, because we are testing the game and the game renders things. Like, one reason why you have confidence that when you deliver a game to people it's going to run correctly is that you tested it over and 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 over. And this is part of that, right? I want to see if something's wrong on the screen. I want to know if things are slow. Like, if we weren't rendering right now, we wouldn't really know that the rendering is maybe kind of slow, right? So there's that. It bothers me how we seem to have lag at the end all the time, but that might be that those are old tests. Dr. Disrespect posted that he has no idea why Twitch banned him. Wow. If they won't even tell him, that's nuts. Although it's par for the course for modern, quote, tech, unquote, companies, but Man. All right, that level needs a little less fog. Publicity stunt? I don't think so. Like, Doc loses a lot of money every day that he's down. You think he has a good idea? I don't know. He says they have not notified him, which I guess means he could know, but come on, like, you know what you did is the classic thing that people say when they're abusing their authority in a questionable way that doesn't conform to any kind of rule of law. Like, that's just what they say. How far back have my games had the Benny test? Never before this one. Like, this game is particularly amenable to that kind of testing. Braid wasn't, Witness wasn't. So we didn't do it on those. We had different things that we would test, but we didn't test this way. How do you set up and automate these tests? Is there a framework you've created? What do you mean by framework? We save out the moves and then we load in the moves. You know, like, I mean, we're programming the whole game, you know, so like we just add this to the game. It's not like a framework. It's just more game, you know? Then compare to, you don't compare to anything. You see if at the end of the playback, the level is in a solved state or not, right? If it is, the test passed. If it isn't, the test did not pass. Yeah. Are some of the water levels on an older version of the water rendering? Yes. In fact, and the water generally doesn't look particularly good during Benny test anyway. So, you know, it is what it is. Watch the permaban be for like some ridiculously mild thing that he said that somebody decided to classify as hate speech. Or something, right? That's just I have no reason to think that except that that's what would happen. Because, you know, he trash talks all the time, right? So if you accidentally, like, let's say let's say you said that Shroud was mentally challenged for going to Mixer, but you did it in such a way that you used a word that is lately being considered offensive. Is that hate speech now? Do you get permabanned for that? Maybe. I don't know. If it was mild, wouldn't they tell him? No, because telling people what happened is the first step in them disputing your account of what happened, right? Whereas if you just don't ever say that and you just ban people, then you're fine. He was talking about David Icke shortly before he was banned. Some are saying that was promoting far-right conspiracy theories. Oh, I mean, yeah, that's a place where modern quote-unquote tech companies are awful. So, I mean, I've never seen any David Icke stuff. Isn't he like the 5G coronavirus guy? Like, yeah, I don't think you should believe what that guy says, but like, I don't think you should ban someone for mentioning what he thinks. Like that seems. I mean, that simultaneously seems crazy, but also I'm not surprised, and that's where we're at today in 2020, right? He's the lizard people guy. You can't really combinatorically check everything in this game. The space is too big. Like, look how long these tests are taking, even when we know the right answer. And like, there's all these timed elements. You can't just pick moves. You have to pick what time to do the moves. It would be a mess. Let me check our estimate code. I might have made a grievous error. Nope, that's only for controller proc. All right. I mean, he could have gone to Mixer until Mixer shut down. Fuzz testing really is easy. No, it isn't. Fuzzing a game like this is pretty hard. Because it's very easy to get stuck in small portions of the space that don't resemble what players will do. It's like, it's hard in the same way that it would be hard to write something that gets all the way to the end. It's hard to write something that fuzzes this meaningfully. You could sort of start to do it by, go to each level, start playing the playback here, and then maybe stop after a certain amount of time, and then start doing random moves or something. And that's kind of how you get into different interesting parts of the state space. But that's still not going to cover a lot of the state space. It's really hard to fuzz things like this automatically. You would want a deep neural network to do it, honestly. He put pineapple on his pizza. Oh my God. Doc. Deep neural network chess program is currently losing to hard-coded C++ engine. I mean, is that Alpha 0 or is that just some other random chess program. Welcome, new subscriber. Welcome to Zombocom. You can do anything you want at Zombocom. The only limit is your imagination. Welcome to Zombocom. Boy, this Benny test has taken a while, everybody. It seems like it's just taken longer and longer for no reason that I understand. I should have timed it. I can come back and look at the VOD later to figure out. Maybe there's just more levels. Maybe Zach added another 300 levels. This one's supposed to fail. This is a known fail. I stream and do everything from one computer, but it is not usually a laptop. It is only a laptop when I'm traveling. I don't tend to listen to music or podcasts. Oh, you can't listen to podcasting program. Who are you kidding? That's not a thing. I don't usually listen to music in program either. Am I getting to the point where I could do with a separate PC for running the tests on? Maybe, but I also, I want to see the results of the test before I do anything next. And this is the thing too, on the question of why do you not make it do this headless? It's like you could do that, but sometimes the impulse that makes you make things go fast is that they're slow, right? So this is really slow now, and I would like to figure out why. And if it's just GPU particles, it's like, okay, at least we know that. That'll get better after we move off OpenGL. In the meantime, we can turn them down, whatever. Casey listens to podcasts while programming. No wonder 1935 isn't out yet. If you have to choose one, good chair or good keyboard, I mean, how bad is a not good chair, and how bad is a not good keyboard? You have to quantify. Benny test has been running for 35 minutes. Are you kidding me? This is crazy. Why is it so slow? It should, in theory, be faster. We're going to have to check. It's possible that someone besides me is slowing it down in some way. Maybe some kind of content update, maybe the animation system is just very slow. Okay, so the problem is we have to fix our damage. So we may not discover tonight why it's slow. That was a new level. This is my level. This is also my level. That wasn't correct. Weird. Are these tests kind of like functional tests in web development? I don't know what functional test means. I don't pay attention to web development. I have very little respect for it. So it is what it is. Whatever web people call something, you're guaranteed that it's actually an idea from the 1960s that web people didn't know existed and made up their own name for. All right. That's just how it is. That's just reality. Trying to understand what I'm aiming to see with those tests. I'm aiming to see if the tests pass. They're tests. I want to know if they pass. You're a huge fan of outputting ridiculously verbose logs and letting something to digest and log it later as part of metrics. I mean, The problem here is that I expect fails of the tests, but those fails do not necessarily represent a problem because we changed some things that would change the outcome of some events because we changed the way that we determine when some transactions commit. And so I don't want ridiculously verbose logs in this case because all they're going to tell me is what I already know. But it's going to take even a lot longer to generate them. You find it's pretty sad how elitist and condescending I am about web development, even though I know so little about it. Dude, I went to one of the very first web developer conferences in the world, right? Hosted by O'Reilly and Associates. Mark Andreessen was there when he worked for NCSA, like before starting Mozilla. All right. Pei Wei was there, who is my friend from Berkeley, who, by the way, wrote the first web browser that had an embedded language before JavaScript. All right. I was there because we were making some proposals for HTTP and different ways of referring to things besides the URLs. Like, dude, you have no idea what the hell you're talking about. Were you even born when I was at this conference about web development with all these people that you know who are famous before most people in the world even knew what the web was? This was in I think I might have just accidentally said 2000. That was a different conference. This conference was in the 90s because it was while I was still in school it was after school, but before I went off and worked on stuff. So this was like 94, 95, maybe 93. Like, you literally might not have been born back when I was doing web development and consulting on web standards. Like, it's insane how, what words did you use for me? Elitist and condescending. It's kind of crazy how condescending you are being, not happening to know my particular history. Getting defensive just feeds the trolls. That is true. It's true. It's just, I mean, the problem is, here's the reason why it triggers me a little bit. Wow, why is this so slow? This is kind of crazy. Are we running a debug build accidentally? I hope not. We might be. Like, what is going on? The reason this annoys me so much is that I think computers are in a pretty bad state right now. And the reason it doesn't get better is because people don't admit how bad it is and or don't know how bad it is. And so, like, those people are kind of the problem. Right? And so the longer this goes on, the more irritated I become with people who defend how crappy computers are. You could just output logs and then maybe know why it's slow. No, that wouldn't. Outputting logs would make it slow. How do you profile a massive game? Well, by using profiling tools. How can logs be slower than rendering? Very easily. I mean, it depends on how much you're logging, of course, but very easily it can be slower. I did write my own web server at one point. Do you know that? Your favorite is loading website from desktop and seeing clearly it was designed for mobile. Oh yeah, that's the best. How does Epic do the giving away of games for free? Yeah, they sign deals with developers. Oh my God, this is taking so long. But we need to do it. But like, I don't... This is really weird. We must accidentally... Let me Control-Alt-Delete. We're not going to kill it. But no, we're running the release build. I mean, we added iProf, but we're not profiling that many zones. I don't think it should matter that much. And interestingly, it's only the time tests, right? So the untimed tests blaze by. Some of the time tests blaze by, like this one. But some of the timed tests are very slow. Let's try turning this up. 50. All right. Some of these are blazing by. Like, look how slow this is. Look how much those other things blazed, and look how slow that is. So there is a problem with timed tests. I have some suspicions about what it is, but I don't actually know. So we're going to have to see. The Russians are slowing it down, maybe. Am I running on a desktop? Yes. It looks like the ocean is slow. It does seem that way. I mean, I would say that that is kind of likely. And in fact, here's my suspicion. My suspicion is that maybe the ocean simulator is running, or some part, there's several things that simulate for the ocean. I wonder if part of it is accidentally simulating for the whole time step every time we do a sub-step, right? And so it's just doing tremendously more calculation than it should. But yeah, so it could be the ocean, but it could just be timed levels, right? But I feel like it is something about the ocean. I feel like that is a thing. It's just, ocean also often implies timed levels. That's all. And it's so weird because this level is really slow, but like I don't even, it's hard to imagine why. It's not a big level. It doesn't have a lot of things in it. It's not outputting warnings about something being wrong. It's just frickin' slow. Gonna have to look at that. And again, somehow it got slower. Like this is slower than the Benny tests were on my laptop last week or even a few days ago. Like it's not spamming transactions. Now, we have somebody else on the team has been working on shader stuff a lot. So maybe that did affect things in some way. Like that level had water but no timed stuff. Did you see how fast it went? I think it's timed stuff and water in conjunction. I hope we get to debug that tonight. I have to fix the broken levels first. Disable water rendering and rerun the Benny test. It's just not that easy, dude. Okay? It's not that easy, and we're doing other things right now. All right? Do you get that? That we're doing other things? We have to fix all these fails that we have. All right, that took freaking forever. But that's not even the problem we're working on right now. I have to fix all this stuff. Why did Heroes 1-1 fail? This kind of worries me because there shouldn't be anything timed there. It succeeded this time. We would have been at 30. Let's try it at 30. Like, look how fast that goes, man. Like, what? Why did that fail? I think there's another problem. Let's just say we don't know what was going on there. Let's try some of these other ones. We can use this one for figuring out why it's slow. All right, so that failed the same way, dropping the gem into the water right there, which is fine. That looks like a legit fail. Whoa. Haha. Okay, that's definitely a problem. That is something I did before the stream. So on this level, you're obviously supposed to go here while there's like a momentary blockage. All right. So I am willing to, I'm just going to try a couple of these, and assuming that it seems consistent to me, I'm willing to just check it in this way. And we can look at the Benny test problem. Wait, why are these guys not moving? I mean, that's a problem. I might have broke that with something else that I did. So those lilies are just never... Well, rip, I can't solve this level. Okay. This is definitely a problem. Let's put that at the top. Heroes 1-1 I'm a little worried about for other reasons. This one is probably just timing. Yeah. Oh, I just died because I moved at a different time. Oh, you know, the problem is our transaction time doesn't account for running. So like, even if we're going real fast, we're pretending like it's slow. All right. We need to do something about that. Oh my God, okay. Have I experienced a shortage in users for bug testing? I mean, I wouldn't use users for bug testing. I would hire people to test. Is the gem supposed to skip? No, it is supposed to sync. If you can't hire people to test, then test a lot yourself. Okay. Yes, the flaw in my plan, and the reason why we didn't want to document it yet is it was really funny at that conference how everyone was really annoyed at Mark Andreessen and whoever the other dude was who was working on NCSA Mosaic with him because they added the image tag to HTML because they wanted to be able to draw pictures on a web page. But everybody else on the web committee was like, dude, no, we need to spend weeks or months to talk this over and come up with the best way to do it. And he was like, no, fuck you, image tag. It was hilarious. That was the big scandal of the month. Did he actually say those words? No. Well, not that I saw. Image tag go burr. That is exactly right. Okay. So we want this get run speed, which is making me nervous, but frack. No, we don't want that. We want the one based on buffered moves. this thing. Okay. We're going to try that and see if that, like, that still probably won't match anything exactly. Let's do B guy. But it might actually solve some of these problems. Okay, that wasn't the one that was failing. It was this one. Yeah, he still died. It's not that surprising. Honestly, we should just always use shouldn't use this. Okay. So now I really do want to figure out why it's going so slow, because we need to be able to Benny test this game. And let's try this. Let's just see where it's at. Yep, it's all in particle emitters. There might just be a lot of particles. So there's 30 calls to update emitters. And each one of them takes like 10 milliseconds. Now, why are there 30 calls to update emitters is the question. And the answer is because timed tests work a little differently. Okay. What we're going to do is we're going to modify update emitters slightly. Okay. Here's what we're going to do. If we're currently playing a test, we'll do one thing, otherwise the other thing, right? But why is it only timed tests? It's because the round trip to the GPU takes so long, and we do it 30 times, right? Okay. Okay. So time tests are weird because we want to run the game like it's a long story. I probably should do them differently than I do, but I don't. It has timing. Test time rate. We're going to try to run the particles for the same amount of time, just in one time step, and we'll see what happens. All right. It is substantially faster, but not totally faster. We still spend a chunk of time in update emitters. Mostly in animation player eval. Which is kind of weird. We knew that though. That goes way back. For a long time ago, I was like, I think animation player's kind of slow. Drawing the game takes a long time, maybe because there's a lot of particles. So, like I said, because we're testing the game, I want to be running some particles. Because that could reveal bugs having to do with particles. It's just... It's maybe... See, it's not really faster. Okay, this is really weird. See how it says count of 8? That's like... Okay, hold on. That might be... Whoops. So let's bring this up, unpause. We should see update emitters with a count way less than 1. It should be 1/30th when we're testing. Let's see. Pause it. It's 1. That's too much. And why is animation player eval? Oh, right. Yeah. Since that's slow, we could skip it if we're not rendering. So animation player eval is 90 because we're at test playback rate of 30. So we're running 30 loops per draw cycle. And then there were 3 things probably that had animations on them. except that doesn't even seem right because there's only one character in that level. We're going to have to look at all these things. There might be some crazy stuff happening. Like we might be animating everything 3 times. We might have been doing that the whole time that the game existed. Why would you sub to the Bob Ross channel? Well, Twitch Prime money got to go somewhere, man. So if I unpause this right now, we're calling animation player eval 3 times per frame. That doesn't seem right to me. There really should only be one entity here. Oh my God, we're calling find type at 1,000 times per frame, guys. You see that? Thankfully, it's only 1/4 of a millisecond anyway, but like, you shouldn't be calling things 1,000 times per frame. That is not how it goes. That was weird and it didn't work. Like if I have something selected, does it lose the index as it moves around? Yeah, we're going to want to fix that. So many things, although maybe that's annoying. We need 2 different concepts. Okay. Well, we did fix some things. There's definitely still problems. 1,000 times. What could even be doing that? Something crazy. That's something that maybe gets pathological in bigger levels too. But we're not going to worry about that yet. We're going to say animation player eval, because that's happening 3 times. And then we're going to say why update emitters. Because I don't think that should be 1 time. Although, actually, maybe it should be when we're testing, because we only draw iProf when we render. Oh, yeah. No, that's okay. I don't think there's a problem there anymore. I mean, it may still take too much time. We'll see, but okay. Animation, draw game 3D is 3 times. I'm not sure that this is for shadows and all that stuff. Like, what? Why is it 3 times? I mean, for all we know, there's a profiling bug or a compiler bug that's causing something real bad to happen. You know? It's quite possible. I mean, I am not sure what to do except to run a debug build and see if it's really happening 3 times, most frames. Seems weird. Okay, this definitely... Why was that in if developer? Where's the zone here? Okay. Okay, no. That's actually draw game 3D. We're getting screwed by the way that we're doing the zones. So draw game 3D is 3 times. That one that's showing as draw game view 3D, I don't think is draw game view 3D. And we might be having the same problem with update emitters. I'm going to move to explicit zone names for a while until we fix this. I mean, maybe we go to here and where we get the name, where do we get the zone name? I forget. I thought we did everything in here. I just did this the other day. Stupid get zone index. I remember that. Stupid get procedure name. right, this is where we're getting nutty. Oh, not location. Hash location. All right. Whoa! Okay, we don't like the T print. Right. We want S print in this case. Absolutely S print. All right. So, why are they all 1.7? Oh, because it's in the macro, bro. We need to make so many problems. Okay, I don't want to rat hole on this. Lol. That doesn't tell me where it is, though. It just tells me that there's different zones. I'm concerned, though. I am concerned. So now that 1084 says find gem and slot it position, which is one zone up from find type at. Did this like make it work better? Okay, anyway. Are we calling draw game view 3D 3 times per frame or not? Let's determine this, okay? We're going to run this. We're going to go to draw, right? We're going to go draw game view 3D. Okay, breakpoint. We're here in do one frame. And then we're just going to see next frame, right? That breakpoint there. That breakpoint there. I mean, maybe this is multiple times for some reason, right? Nope. Nope. Let's just say, okay. Do one frame, 3D. So we're only calling this once. Now, the thing I don't understand is why it says there's a zone in draw game view 3D. That seems to be a bug with the, like, who is getting that? You know what? I bet my stupid function name get is 1 off. I bet it's giving you one function too high up the stack because I'm dumb. So this is marked inline, bro. Although I don't remember how stack trace is supposed to work in this case. Inline doesn't actually work that way right now. So this will break later, but we're not going to use this later. I think this is the problem there. I think this will make more sense and we can take out our random number now. Yes. Okay, so now this makes more sense. Draw game 3D 3.0, that's fine. Draw game view 3D, we don't see it all. Draw entities opaque, find at position. Okay, this is all making more sense to me. This is better. Okay, let's get rid of our random number. Then, are we calling animation player eval 3 times? Maybe not. Yes. That doesn't seem good. It's very suspicious that that's 3 times. And draw game 3D is 3 times. But animation player eval is supposed to be called from simulate. Whoops. Update animation graph, take a note time. Update animation cosmetic is supposed to be what's calling animation player eval. I don't understand why that says 3 times. Maybe I made a mistake and I just literally am calling it more than once. So update animation cosmetic is being called 3 times. Maybe some entities have animation players. Maybe rocks have animation players on them. They do, don't they? Even though we don't animate them right now. That's my theory. My theory is that rocks have animation players. Let's see. Whoops, no, wrong file. Wrong file. Player. Okay. Here we go. So I could actually put this breakpoint here instead of here. That's fine. So why did it delete? It's a rock. Rocks have animation players on them. Let's not do that right now. Oh, because it has a skeleton info. Okay. That is a thing. How's it going, everybody? How's it going? All right. Animation player eval is now called one time. Mystery solved. Those extra calls were probably not that slow, like, because those rocks weren't playing animations. But yeah, okay, so update water particles emitter, definitely taking some milliseconds. We know that, like, it's very slow because of syncing buffers between GL, and it's going to be just kind of painful until, well, maybe we rewrite that one day, because there are some things we can do to make it a bit faster. But it'll also get faster when we go to DX12. Okay, so this is not so bad anymore. We're not as confused by what we see. We would like find at position to not be called 1,084 times, in my opinion. Now, I realize that your lived reality may be different from that, but I do not think it is appropriate. And it was from find gem and slot at position. Okay. The question is why? Why are we calling that 1,000 times per frame? Okay, gems. Is that what file it's in, or is it in power? Gem and slot, right? Update control prompts, all right? Well, that's once per frame. That's just trying to say, hey, draw control prompts, draw HUD. Wait. Let's just put a break out here, do one frame. Do one frame, find gem and slot, do one frame. So maybe it's not find gem and slot. Maybe that was just the first thing that created the thing. Okay, so it was find at position, right? That's in proximity grid. See, when you have little bugs like that, they get confusing. Find at, okay. Why are we calling this a trillion times? Let's see. Find type at, update control prompts is on enabled entry. Do one frame, find at position. Is on door, check for victory. Is on door. Update signs. Draw off-screen oceans. Okay. This is running per square of the ocean. 3 times per frame. Because remember, draw game 3D is getting called 3 times. Right? Draw off-screen ocean stuff. Probably, maybe that only gets called 1 time. Okay. Okay, let's see. Yeah, you don't want to do a proximity grid query for every frickin' ocean square. That's not okay. This is the kind of thing, though, that it happens in games. Like, games just get big and you write some code and you're like, I didn't realize I'm doing that. Probably all software, but in games you probably actually notice eventually that you did that. Whereas if you're writing Chrome, you just don't. And then Chrome just gets slower and slower. All right. Find at position. What were we looking for? do one frame. Draw game 3D. The draw off-screen ocean stuff is only getting called once. And that's calling find at position 1,077 times. Is that how many squares there are? Let's see. In the ocean, there are 37 by 32. That sounds about right. I mean, that's not 1,077, but it's almost. 1184. So it's like one of those dimensions is like, yeah. Anyway, you see what I'm saying? It's approximately once per square. So, well, let's see y again. Okay. Oh wait, this is the start of the level. That's not what we want. Okay. Okay. Whoops. Okay, is ocean filled? That is not what we want to do. We do not want to call that. That is the wrong thing. Okay. So, yeah, I did not write this bit of code. Whoever did this has another think coming, man. So we should just be able to say info.filled, sort of. Okay, anyway. We don't care because it's not really being used for anything right now. All right. So, hey, look, nothing's getting called 1,000 times. Well, nothing that we're profiling right now is being called 1,000 times, which doesn't tell you much because we're not profiling most of the program. Okay, test. This is super debug build. It's let's do that again. It's much faster than it was. If you guys remember, this level took like 30 seconds or more, a minute in release build. This is like super debug build, and it just takes, 7 seconds or something. So it's way faster now. But let's see. So, we don't have to draw. We don't have to do animation player eval except when we draw the frame as well. So, game should render. See what happens there. So it's definitely a lot faster. We're not seeing animation player eval. We are seeing update move transactions take quite a bit of time. But you know, that's optimization. Like you fix one thing and now another thing is the bottleneck. Right? But Benny tests, even now, if we don't, like that was weird because like, it's not slow now. Like it's only slow the first time. Like update and move transactions never got really slow. It like only, did we get our weird zillion transaction flood message? No. So there's something there. There's like some percentage of the time update move transactions can get slow. But look how much faster that is, dude. It's crazy. Let's start running in Debug. All right, here we go. We caught one where update move transactions. All right, let me stop the test. Update move transactions took first 127 per. That's not surprising because we do have to call that one a lot. Like the body of the function itself took a ton of time, but none of the callees did. This is when I wish we had turned on the auto profiler, but let's manually profile a bit. Again, this is not so bad because it's super debug build, but I just want to figure out what's going on. So let's go. I mean, maybe sort transactions, maybe I mean, this calls some things. Is supported, maybe gets called. I kind of don't know. I could put some zones like in the middle here. Let's put profile zone named update move transactions middle. See how that goes. Super debug build. No, I don't mean super debug in the sense of extra debug info, just that this is using the x64 backend that I wrote most of that generates very poor code. All right. All right. So Update move transactions middle is a lot. It's not all of it, because move individual guy spikes up sometimes. Animation graph takes a long time sometimes. We really need to get that automated profiler back, folks. It's just, I kind of don't want to switch over to manual mode. Or switch away from manual mode till we make manual mode good. It's just, we just don't have information on what's taking the time. All right, let's just chase it down. So it's after the middle. All right, so we can do this again. It's after this, but before it returns. So we go 3 here. That, I feel like that might be too far. Update move transactions 2. Well, that wasn't the full Benny. Let's do the full Benny. See, the problem is at the beginning it's like loading animations and stuff, which is really slow, which we don't really want to count that. That might actually be, let's see. Like once it gets rolling, so 3 doesn't have it, right? So 2, hold on. 2 has all the time there. So we'll put a 4. So we have, so between 2 and, well, between 2 and 3 is just this frickin' loop. So like, and that's 1 per completed transaction, so it shouldn't iterate very many times. Let's just put 1 here. All right. This is a descendant of iProf, which is a profiler by Sean Barrett. That's a descendant of a profiler that I put in Game Developer Magazine in the 1990s. I believe that's an accurate claim. So update moves transactions 4 is not really appearing here. Let's put, because loading animations, because we know that's slow, all our tests are taking too long now, man. Let's put 5 here. This is how you do it. Sometimes start putting no check-ins on these. Okay, this would be, again, much better if we had the automated zones turned on, but like, man, one thing at a time. You can't do everything all at once. You know what I'm saying? You'll go crazy. Okay. Maybe we'll do this next weekend or something, is get the automated thing back running. I've got so many other things to do. I've got so many things to do, people. What was I going to do? I'm worried about this taking too long thing now. It's fine. So we added a 5. Oh, yeah, loading an animation. We'll put one there. Because that's a thing that we know won't take time in the release build. Get more interns. Well, I mean, the thing is, interns don't have many years of experience working on your project. Sometimes you need that. Okay, like all these spikes are loading the animations. So I'm actually not going to worry about it. I'm glad I just went straight there. See that? Every time we hit a new character who's doing a new thing, we like load some animations for that guy, but at some point we will have loaded all of them. Like that introduced priest, bard. There's a bunch of characters, but at some point we'll have them all. Boy, that function sure is slow though. Maybe we need to put some no ABCs on the matrix multiplies. See if that helps. Anyway, yeah. By the time we get here, we're not loading that much. We're still loading a little bit. This is so much faster, guys. Like, this is still super debug. This isn't even release. We're not even trying to play it at 50x or whatever. All right. Okay. Particles still take some time, but that's something we could do another time. Okay, let me just look. So load sampled animation does a lot of math that it probably shouldn't need to do. But let's just check our operator times for matrix. What? Oh, because we use X-form states. Okay, let's check. That's local to here, but we don't even use array there. Okay. This thing is what we're calling, and oh, that's just a, yeah. This is probably a slow ass thing. That's a bug on my list, that shear gets destroyed sometimes. And I look there and I see this comment, this destroys shear, don't use this. It's like, oh, that's what that's about. But it's not that function. That's slow. Interestingly. Let's see. Load sampled animation. That is likely to be a problem. Our animation format is not what you would wish. It's not what I would wish. Yep, get relative to parent is up there. It is really, though, less than 10%. Okay. I bet get matrix is expensive. That's a place where we could use some no ABCs. No. Guess we don't call it that much. Is it in text file handler? Is that right? Do I remember my own syntax? Yeah. I bet it's in parsing floats. I bet it's our frickin' Visual Studio float parser. Read X-form state. Oh yeah. Oh yeah. That's going to be in basic, yeah. So string to float is probably slow. Read X form state. Oh my God. Read X form state is the culprit. Oh my God. Okay, I'm not surprised. That's what, actually, let's see how many read X form states we have. Yeah, see how we're calling it 6-digit numbers of times sometimes, because that's just how many of those are in an animation file. Look right here. Well, we can get rid of this if. It's not going to matter because it's not the slow part. But like we said, if the line is empty, return. So we don't need that. Yeah, it's all string to float. For string to float right now, we use Visual Studio scanf, unfortunately, on Windows, which is really slow. So like one thing to do there is not to do that. But the other thing to do really is to save our animation files in the format that we want to load. Let's just verify. Okay. We can't put zones here because nobody but us knows what they are. Oh, and also because this module doesn't know what the hell they are. Interesting. That's an issue. That is an issue. That is an issue. Okay. So we're calling A to F after doing all this weird stuff because like you don't, we just want to call STB scanf, right? We'll see if this helps at all. Okay. Yeah, I mean, it seems slightly faster because I'm not seeing the numbers overlap as much. So the no ABC probably helped a little bit. But yeah, that's definitely a thing. Get relative to parent is cheaper than I thought. It's really all the frickin' parsing, guys. And honestly, parsing should easily be more than 10 times as fast as that. It's just, you know, it's a Visual Studio Standard library, so of course it's not good. Okay, so let's do a release build. And we're going to Benny test it at 50x, and we're going to time it. Actually, we're going to go 60x. And we're going to see, I don't even know how long earlier today's Benny test took. At 35 minutes, somebody told me it was 35 minutes, but then it took a lot longer. So we are going to see. Yeah, it was easily over 40. I feel like it was like 50 at least. Now 60x, might cause, I don't think it should cause more failures, but let's see. All right, ready? Like we knew there were some fails at the beginning because that's just what happens. We should maybe make the flash shorter when testing. Definitely going faster. Yeah, I mean, there's going to be some fails from the move timing thing that we did earlier. I don't think we should have more fails from going to 60x, honestly. In fact, we could go to 120. Although maybe that's ratcheting up the number of fails that we have. It's quite possible. I think there's something with beams. Yeah, we're failing more for sure. So we have some other stuff to debug. I think not tonight because it's bedtime soon, but like maybe we do a 30 times playback versus a 120 times playback and like see what on one of these levels that fails and see what the difference is. Okay, let's turn off the transitions. Because that's headache inducing, all the flashing at this point, even for me. And I think it'll be better if you can like see, wow, okay, yeah. So we definitely have some weird stuff happening. So we're going to want to debug that. Oh, I forgot to time it. Flashbangs. How will I sleep now that I've been flashed? Getting flashed makes me tired, man. Sleep more easily. Check the timing on the VOD. It's true. Oh, so much flashing. It's crazy how much. Okay. I think it's safe to say that that was a lot faster. We also failed a lot more. But, so like what? Like now it succeeds. Hold on. You know, it might be something simple about when we go to one level from another during a test, we maybe don't do something correctly. Could it have failed simply because it didn't have enough time to finish each level? I don't think so, because these levels are not timed. They're not running timed tests. So look how fast that was. Fail early victory. That was just me hitting the key early. So these are all succeeding. That's the weird thing. They're all succeeding when I hit the key to test just that level, but a bunch of them failed in the auto test, and that matches stuff I was seeing earlier today. So it doesn't just happen at 120x like this. It happens generally. So that's something we're going to have to figure out. Look at how fast we are, man. It's like you can't even see it. We are definitely missing some bone names. Okay, yeah, this is like all these levels succeed. We're going to have to put together a Benny test that's like maybe just Heroes of Sokoban, so that it's fast to run the test, but we run a bunch of those levels in sequence and just see what happens, right? So like these Arcadia levels, these are the ones that we were playing at the beginning that were failing, and they're super succeeding right now. So I'm not sure what the deal is. Take a break. 5 hours ain't that long. I'm just making an AutoHotkey script that presses the button. Yeah, well, that is one way to do it. Look, the game works fine, everybody. Okay, that's going to be fun. It's going to be fun running at 120x. Let me try fallible. I just want to know. Because this one has timed elements of falling and stuff. It's working. It's working. Oh, it's not working. But that one I think didn't work already. Okay, so why did Here's a Sokoban not work? We'll debug that tomorrow. Or we'll try. We will try. I mean, at the very worst, we can just find some subset Benny test to run that gives us fails that we don't get on individual, and we'll just figure out what variable is not being reset. Why not make a fast variation of the Benny test that simulates all the levels but only shows the fail test as a replay, levels as a replay? Because it's the same question everybody always asks me, except different, and I'm tired of answering it. Okay, thanks everybody for coming by. And yeah, we got problems, but they're smaller than they were this morning. I'm not going to check this in yet. We're going to work on it some more tomorrow, and we will see how it goes. Thank you, everybody. See you later.